I'm dreaming of a white Christmas. Oh, hello there. How are you today? Are you dreaming of a white Christmas? Well, I have some good news for you. We are going to make our very own snow this week. And you'll be able to give your family that white Christmas they've always wanted. Welcome back to the Lee County Library Science Club. It's great to have you with us. Just a reminder, please make sure you have your parents' permission and some supervision when you're doing these experiments. Now, let's get to snow. Before we can work on snow, though, what is snow? Well, as most of you probably know, snow is water, right? It's frozen water. But if you took some water and put it in your freezer, it doesn't come out as snow, does it? It comes out as chunks of ice. So what happens with snow that makes it different from ice? To understand that, we have to talk about the phases of matter. So matter is all things, atoms and molecules that are all around us that make up stuff. And matter can exist in generally 3 different states or phases. There are others, but they're rare. We're not going to talk about it right now. But the main 3 you know of: solid, liquid, like water in a glass, and gas. The air all around us is gas. We've talked a little bit about all of that before, but today we're going to talk about what those states of matter are, or what those phases are, and how the matter changes from phase to phase. So let's look at the definitions. Solid matter is when the particles will hold their form without any outside support. Okay? So this box, all by itself, stays the shape of a box, right? Because it's made out of solid cardboard. The shaving cream inside this can, if I were to remove the can, the shaving cream wouldn't stay in this nice cylinder shape, would it? No, it would kind of fall and spread out on the table. And so that is what a liquid does. The particles are loosely connected enough to flow and fill in the shape of the container they're in, but they're still densely packed enough to respond normally to gravity and to remain kind of all connected in one area. The last one is gas. Like I said, the air all around us is gas, right? So when particles are in a gas, they are not really connected much anymore. They are floating free of each other, flying all around. They are affected by gravity, but really not that much, right? They can float all over the place. So those are our 3 phases: solid, liquid, gas. But anything, all kinds of matter, can change to the different phases. Water is the one we see most often, so I'll use that as my example. But even something like the metal on this shaving cream container can be found as solid, liquid, and gas. So how could you change something like metal into its different phases? Well, all it takes is either an increase or a decrease in energy. Remember, we've talked about in the past, molecules are bonded together, and each molecule has a certain amount of energy within it. So as each molecule gets more and more energy, the bonds to hold them together have to be stronger and stronger. Eventually, they'll reach a point where the energy within the molecules is stronger than the bond between them, and they'll break off and change their phase. Now, these different ways of phase changes are what we want to talk about with snow today, and what makes snow kind of special. Let's start with the easy ones. Moving from a solid to a liquid, we just call that melting, right? If you have an ice cube and you bring it out into the warmth, it will melt into water. Okay, so that's solid to a liquid. Now you have your liquid and you go to a gas, that is called evaporation. We've talked about that before too. Right? When you boil water on the stove, the steam coming off is water vapor. That's the liquid evaporating into a gas. Now once it's a gas, and you want to turn it back into a liquid, that is called condensation or condensing. The air, the water vapor, comes together and forms back into liquid molecules. Now once again, going from liquid to solid, we have freezing, right? Put some water in your freezer at home, it freezes into solid ice. Now, there are two more phase changes that we haven't talked about yet. And you may be confused because, well, we already went from solid to liquid to gas, back down to liquid and solid again. Right? We melted, we evaporated, we condensed, and we froze. But sometimes matter can skip the liquid phase, and it'll jump straight from solid to a gas, or from gas to a solid. So moving from solid to a gas is called sublimation. Now if you've ever seen some dry ice, or sometimes they use it in like a smoke machine, dry ice is carbon dioxide that's been frozen, and when it warms up, it skips liquid and goes straight to gas. Going the other way, from gas straight to solid, is called deposition, or the gas is being deposited as a solid. Now that is what's important today, because snow, for the most part, is water vapor that has been deposited right into ice crystals. And that process is how it gets so small and so intricate, and what makes it so nice and light and fluffy. Now so far I've talked a lot about warming and cooling things, and that's because for us, changing the amount of energy within matter, the easiest way to do that is by using heat. Now when it comes to making snow, with water particularly skipping the liquid phase, you have to take into account the other thing that can affect phases, and that is pressure. You can make something, it can be really, really hot, but if you put enough pressure on it and push it together and force it to close down its space, you can still have a solid at really hot temperatures. Now the reverse of that, if you have very little pressure, which is true up in the upper reaches of our atmosphere, there's not a lot of pressure up there. That's why there can still be water vapor up there even when it's really cold. But if you get just enough pressure, then it will skip the liquid phase, and because it's so cold and there's more pressure, the water vapor turns into ice crystals and we have snowflakes. And snow really is kind of a unique substance, isn't it? Those particles are definitely solid, but they are so small that they almost kind of behave like a liquid, don't they? They'll flow together, they'll get pushed by the wind. When snow falls, it kind of fills in whatever it falls onto. And those are characteristics similar to a liquid. But those particles hold their shape, and if you take some snow and pack it together into a ball, it will generally hold that form. So it kind of behaves somewhere in between a solid and a liquid. And that same property is what we're going to try for today. And in order to do that, we just need some very simple ingredients. We need some baking soda and some shaving cream. And you probably will want some kind of bin or bowl or big plate to work on so you don't make a mess all over your kitchen. Okay? Let's get started. Well, say hi to our friendly library snowmen ready to help us with this experiment. The first thing that we need to do is take your baking soda and just pour it all out into your bowl or container or whatever you're using. Okay? The whole box. Get it all out there. And you can kind of spread it around a little bit. If you notice some large chunks, you can break this up a little bit. If you have a sifter at home, you could use a sifter to get it all nice and smooth, but it's not essential for it. Just makes it a little bit easier to mix. So, you're going to take your shaving cream. You do want to shake it up a little bit. Make sure that it's really combined well. And then you're just going to start with some shaving cream. And you're going to start mixing. And it's going to be very messy. But as you mix, that shaving cream should start to combine with the baking soda and come off of your hands a little more. You may have to kind of fold the baking soda over on top of the shaving cream. Alright, so I've got that first bit mixed in there, and you can see it's definitely a little bit fluffier, but it's still pretty crumbly, right? It doesn't quite pack together the way snow does. So I'm going to spread it back out a little bit, and actually this time I'm going to make a little hole in the middle. Going to make a nice little hole in the middle and put some shaving cream in there. And don't do quite as much this time, just a bit. And now you can take the outsides, kind of put it on there, and then push it in and try to mix it together. So there's two criteria that you need to go by to know when you're done and your snow is ready to play with. The first is that when you pick it up, it doesn't really stick to your hand anymore. And you can see it doesn't. The second is that when you bring it together, you can pack it the way you would snow. See that? Now this is still just a little bit crumbly, so I'm going to add just a bit more shaving cream to it. And I'm going to do the same thing. I'm going to bring it together, put a little hole in the middle here. And we're going to do a little bit less this time. There. And again, we're going to bring it together, put it over top, and mix it together. Alright, now we're really close. We're just going to do a tiny bit more shaving cream. Alright, now we've reached that point. You can pack it together like snow, make balls out of it, and it doesn't really stick to your hands anymore. So now we have made our very own snow. Now, as we talked about before, one of the things that's a little bit unique about snow is that it is a solid, but it kind of has a little bit of liquid properties, doesn't it? It's like in between a solid and a liquid. Now, with our mixture here, we have something similar. So our solid that we started with was the baking soda, right? It's powder, so it's very small particles, but they are still solid. Those particles hold their shape. They don't change to fill the shape of their container. But the other thing we've used is shaving cream, right? Now, shaving cream is interesting because it's basically a liquid, but it's a liquid with a whole bunch of gas that's been pushed into it and kind of mixed into it, so it's really thick and frothy and foamy. And that foaminess and the gas that's mixed in there, when you combine that with a solid, a nice good powder like our baking soda, so you'll end up with something kind of like snow that is a solid, but there's a lot of other particles in there that make it behave a little bit differently. You can form it into something like a solid, but it also, on its own, will kind of shift itself into a different shape. So, now you've got some snow. have some fun with it. Alright, you can take a bit of snow, add it together, make a snowball, maybe make a smaller snowball, and maybe one final little snowball. You've got that one final smaller snowball, and there. You can build your own snowman. Now, I wouldn't really recommend making these snowballs and throwing them around your house. Otherwise, you're going to have a big mess to clean up, and Mom's probably not going to be too happy. But I bet you could make some snowballs and take them outside. Maybe hit a few trees with them. And that is how you can have your very own White Christmas this year. Thank you so much for watching. I hope you enjoyed it. We'll see you next time. Bye.